Hey, Algebra 1. So in our notes for today, we are starting our new unit. We are on Unit 7, Linear Functions Revisited. But before we start any of our new topics, I just want to go over a quick review of what we already know about linear functions. So our linear functions come in three different forms. We can write our equations in standard form. That looks like ax plus by equals c. We can write them in slope-intercept form. This one's our favorite. It's the y equals mx plus b. We also have point slope form. That one is y minus y1 equals m times x minus x1. So for this first part of the unit where we're talking about linear inequalities, we're mostly going to be using standard form and slope-intercept form. So remember, in slope-intercept form, we get all of the information that we need. We know m, which is our slope, and we know b, which is our y-intercept. So if I had an equation that said y equals 1/2 x minus 2, then I know my slope is 1/2. That tells me I'm going to rise 1 and run 2. And my y-intercept is -2. So when I graph this line, I start on the y-intercept. I start at -2. And then I use my slope to rise 1 and run 2 to make more points on this line. Then when I run out of space, I can go back in the opposite direction. I go back to my y-intercept, and now I'm going down 1 and left 2 to continue the line. And for our linear functions, we connect all of our points, and that line is y equals 1/2 x minus 2. In standard form, we would have to actually do some work to get to that equation. So in standard form, this equation would look like -x plus 2y equals -4. And then for this, we would have to solve this equation so that it said y equals. So we would add x to both sides. So now we would have 2y equals x minus 4. And then every single piece would get divided by 2. We end up with our y equals 1/2 x minus 2. So an equation in standard form just needs to be changed so that it looks like slope-intercept form. So when we were talking about linear functions, we also talked about their solutions. If we had a system of equations, so if I had two lines on my graph, if I had a whole system here, then the solution to my system of equations is that point where my lines cross. That would be my solution. It's the point that works in both of the equations. When I plug in the x and y values, they both turn out to be true equations. If we're just talking about the solutions on a line, well, that's just any point on the line. Like all of these points are solutions for this pink line. And then the blue point also has solutions at any point on the blue line. So for a line, solutions are just points on the line. For a system, the solution is that one point that both lines share. What we're going to be talking about are inequalities first in our linear functions revisited unit. And an inequality says something like y is greater than 2x plus 5. So it's not y is equal to, so my solution isn't going to be the points on the line. My solution is going to show me any points that satisfy the equation y is greater than 2x plus 5. So if we check out some examples here, we are going to determine if this point is a solution for our equation, 3y is less than 2x plus 5. So in order to check if it's a solution, I'm checking if this x and y value work in this inequality. So I would have 3 times 1 is less than 2 times 2 plus 5. I'm checking to see if this is true. So in this case, 3 times 1 is 3. I have my less than symbol. 2 times 2 is 4, and 4 plus 5 is 9. So 3 is less than 9. Yep, that is a solution. So let's check out one more example together. Number 2, this equation is in standard form. It looks like ax plus by is, well, in this case, it's greater than or equal to c. So I'm checking if I substitute 0 and negative 2 into this equation, where x and y are, do I get a true statement? So I would have 2 times 0 minus 7 times negative 2 is greater than or equal to 14. Let's see, 2 times 0 is 0. Negative 7 times negative 2 is positive 14. So is 0 plus 14 greater than or equal to 14? Yeah, this is true. 14 is greater than or equal to 14. So we could say 0, negative 2 is a solution. So all that means is that point works for this inequality. Try number 3 and number 4, pause the video, take a minute, try these out on your own, and then come back and check your answers. All right, for these last two, in number 3, negative 3 comma 11 is not a solution to that inequality. And in number 4, 1 comma 5 is a solution to that inequality. So if you look underneath at 5 and 6, these show how we graph our linear inequalities. So on a graph, we have our line, and because it's an inequality and we're saying something like y is greater than any of that stuff, we shade in part of the graph to show the side that would be greater than. So in this case, this one would be talking about greater than because we're looking at things that are above the line or greater than. And in number 6, this one is shaded below the line. So this inequality would be talking about things that are less than because we shaded underneath the line. So when we're checking to see if points are inequalities, if points are a solution to our inequality, and we're given the graph, I don't have to go through all that work of plugging in my x and y value. What I can do is just check if that point is on the shaded part of my graph. So if we're looking for negative 3 comma 2, on my graph, negative 3, negative 2 is right here. That is not on the shaded part of my graph, so that is not a solution. When I check the next one, this time we're at positive 2, positive 3. The point positive 2, positive 3 is right here. That is on the shaded part of my graph, so that is a solution. The next one is 3 comma negative 3. Let's make that one green. Is this point a solution? So I'm going to find the point 3, negative 3. And yeah, that point is on the line. So yes, that is a solution. Okay, we're gonna do the same thing for number 6. So looking at the graph, we are going to check if those points are in the solution area. Are they part of that shaded graph? So our first point here is 2 comma negative 3. So positive 2, negative 3, that's this guy right here. Yes, that is in the shaded part of my graph, So yes, that is a solution. My next point is at 1, 1. So on my graph, I'm going to go to 1, 1. Oh, okay, so this point is on the line. In number 5, we had a point on the line, and we said that it was a solution. But this line was a solid line. On number 6, this point is on my line, but my line is a dotted line. So what that tells me is this line isn't actually part of the solution. The solution is only the stuff that's shaded in. The line can't be included. So this time I would say no, that is not a solution. And our last point here is at 1, 4. So at +1, +4 up here, nope, that is not in my shaded region. That is not a solution. We're not going to worry about writing the equations, writing the inequalities right now. We're going to come back to that on a different day. So your first page, your filled in notes from here, job is to answer questions 7 through 10 on the back. These are your practice problems for today. So when you're done, you are going to upload a picture, attach it on Google Classroom of your notes and of your practice problems under our Flex Block assignment for today.